Hello. In this lesson, we are looking at question 13, part C of 2014 HSC Mathematics. This was a common mistake made by many candidates in that exam paper. We're looking only at part C, which was, as I said, a common mistake. The displacement of a particle moving along the x-axis is given by x equal to t minus 1 on 1 plus t, where x is the displacement from the origin in meters, t is the time in seconds, and t is greater than 0. Part I show that the acceleration of the particle is always negative. To get to the acceleration, we need to differentiate the displacement equation twice with respect to time. So x is equal to the first differentiation will give you velocity. So t plus 1 or 1 plus t. First thing I do, I write this in the form of a power. So x becomes t minus 1 plus t, or t plus 1 to the power of minus 1. All I did, I got rid of the fraction and wrote it in the form of a power. Now I differentiate with respect to time, that will give me velocity. Derivative of t with respect to itself is 1 minus this minus 1, the power will come here, becomes the coefficient, and you drop down the power by 1 in the bracket, and you times by the derivative of the expression inside the bracket, which in this case is going to be again 1. So x dot becomes 1, and minus times minus 1 makes it plus 1 plus t to the power of minus 2. That is velocity. We will use it later on. At this stage, we are interested only in acceleration. Then I differentiate this once more to get to acceleration. Derivative of 1 is 0. And again here, plus the derivative of this bracket taken to the power of minus 2 is minus 2 times 1 plus 2, 1 plus t to the power of minus 3, drop the power by 1, and times by the derivative of the expression inside the bracket, which is 1. That simplified will give us x double dot equal to 1 times minus 2, 0 just disappears, 1 times minus 2 is minus 2, and times by this, and this is a negative power again, I can go back to a fraction. And this negative power becomes a positive power in the denominator. Alright, so that simplifies to minus 2 over 1 plus t to the power of 3. Okay, what is this negative? Yes, it is, because the numerator is always negative and the denominator is positive. So as the numerator is negative, and the denominator is positive, so x double dot is always negative. So what does this mean? This means that your particle will always slow down. For part 2, what value does the velocity approach as t increases indefinitely? I write the expression for x dot again, which is the velocity, that was 1 plus, this again is a negative power. I can write it as a fraction with a positive power. So that was my velocity. I wrote it here again. 1 plus 1 over 1 plus t to the power of 2. All right, as the time goes to the infinity, this value goes to infinity, 1 plus t. So t is infinity plus 1 approaches infinity, and infinity squared is infinity. So 1 plus t squared goes to infinity. And you know that if the denominator of a fraction is a very large value, it's the whole fraction becomes 0, approaches 0. So 1 on 1 plus t squared approaches 0. And if this approaches 0, then x dot just will have 1 left for that. So x dot will approach 1. So as the time goes to the infinity, velocity approaches 1. Time is in second, and the displacement is in meters. So that means the velocity will approach that many meters per second. That is all for this lesson. Thank you for your attention.